All right, today we are going on a quest. Think of it like this. We're on the hunt for a secret recipe, the one and only architectural blueprint for building a perfect, one-of-a-kind triangle every single time.
I mean, you see triangles everywhere, right? The pyramids, the trusses holding up a bridge, they're the world's strongest shape for a reason. But what's the magic behind that strength? Well, it all comes down to a kind of secret code, a set of rules that guarantees you'll build the exact same super stable triangle with zero variation. So let's dive in and crack this thing.
Okay, so before we can start building anything, we have to know the rules of the game. And for this, we're taking a trip way back to the origins of geometry, where the challenge was to create these incredible, complex figures using the simplest tools imaginable.
This whole process has a name. It's called construction. And this isn't just doodling, okay? It's a super strict discipline with very specific limits. Imagine this. You get no ruler to measure inches or centimeters, no protractor to check your angles. Nope. All you've got are these two ancient, simple tools. So let's break down our toolkit. First up, the straight edge. Its job is simple. Draw a straight line. Connects point A to point B. That's it. Then you've got the compass. Now, yeah, it draws perfect circles, but that's not its real superpower. Its real magic is that it's like a copy machine for lengths. You can measure a line with it and then perfectly duplicate that exact same length anywhere else you want.
And here's how that works. It's actually genius in its simplicity. You just open the compass to match a line, lock it in, pick it up without changing the width, and plop it down somewhere else to make a mark. Boom, you've just created an exact clone of that original line. This one skill, this ability to perfectly copy a distance, is the key to everything we're about to do. All right, our tools are ready, we know the rules of the game, it is time to unlock those 3 secret codes I was talking about. These are the 3 sets of instructions that, if you follow them, will always result in one and only one possible triangle. Code number 1 is probably the one that makes the most sense right off the bat. Side, 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 or SSS. It's simple. If I give you 3 side lengths, there is literally only one way they can connect to form a triangle. It's completely rigid. There is zero wiggle room, no other option. That one set of side lengths locks in one unique triangle. Next up, code number 2, side angle side, or SAS. Now the order here is everything. You need 2 sides, sure, but you also need the angle that's sandwiched right between them. If you know the length of a side, the exact angle it makes with the next side, and the length of that second side, well, the rest of the triangle just falls into place. It's completely locked in. And our third and final code is angle side angle, or ASA. This time you start with one side of a known length. Then you need to know the 2 angles at each end of that side. Those angles act like laser pointers, shooting lines out at a specific trajectory. And guess what? Those 2 lines will only ever cross at one single precise point, finishing off our unique triangle. So there you have it, our 3 foolproof blueprints, SSS, SAS, and ASA. But, to really get why these 3 are so powerful, it helps to look at the ones that don't work. Let's explore some of the ways these blueprints can go spectacularly wrong, because that's when you really appreciate the perfection of our 3 codes. So let's start with the big one, the one that trips everyone up. What if you know all 3 angles, but you don't know the length of a single side? I mean, AAA, it sounds like it should be enough information, right? Well, let's see why it isn't.
Here's the catch with angle, angle, angle. It only defines the triangle's shape, not its size. You could have a tiny little triangle that fits in your hand and a massive one the size of a building, and they could both have the exact same angles. It's like taking a photo and just zooming in or out. The shape stays the same, but the size changes. So AA doesn't give you one unique blueprint. It gives you an infinite family of them.
And there are other ways these blueprints fail too. For example, if I give you 3 side lengths, but the 2 shorter ones added together aren't even as long as the biggest one, well, they physically can't meet to close the triangle. And that tricky side-side angle case, SSA, oh, that one's a total mess. It's ambiguous. Sometimes it works, sometimes it makes 2 different triangles, and sometimes it makes none at all. It's just not a reliable blueprint. Okay, so let's get back to our winners. SSS, SAS, and ASA. These are our golden tickets. They're the only surefire ways to build one specific triangle. And when you use one of these blueprints to make 2 separate triangles, you get something really special. You get perfect twins. And in the world of geometry, there's a fancy word for that. That word is congruence. 2 triangles are congruent if they are perfect clones of each other. We're talking identical in both shape and size. Every side, every angle, every measurement matches up perfectly. They're the exact same figure, just maybe rotated or moved to a different spot. And following one of our three codes is a guarantee you'll get congruence.
Now this is a really important detail, especially when you see it written down. Look at the symbols. We all use the equal sign, right? But in geometry, equal can just refer to one value, like area. A long, skinny triangle can have the exact same area as a short, fat one. They're equal in area, but they are not congruent. That's where the congruent symbol comes in, the one with the little squiggle on top. That means so much more. It means they are identical in every way.
And here's the real payoff. If you know that two triangles are congruent, you suddenly know everything about them. All their matching parts are identical. So if triangle ABC is congruent to triangle DEF, that's a massive shortcut. It means side AB is the same length as side DE, angle B is the same measure as angle E, and so on for the whole shebang. They are perfect twins.
So, we did it. We've cracked the code for the triangle, uncovering the three perfect blueprints that guarantee its strength and its uniqueness. But that leaves us with a final thought, doesn't it? What about other shapes? Does a square have a secret code? A pentagon? The principles we talked about today, construction and congruence, they're the keys to understanding the blueprint of any shape in the universe.